Hello, this is Bryant Myers, and welcome to another edition of Debunking Flat Earth. Tonight I decided to take a day off from Witsit and go back to my first debate and answer an email that David Weiss sent me, or Dearth, and I basically was asking him, it's like, okay, what is your best proof for the Earth being flat? Send me some of your best stuff. And during the debate, the first debate, I brought up the Himawari 8 and the GOES 16, 17, thinking that was like a just definite proof. And I didn't realize a lot of the things that I know now. And they came back at me with all these different things. And so I said I'd look into it, and I definitely have. And I'm just going to go through and kind of demolish everything they said during that first debate and really show you that the Himawari 8 and the GOES 16, 17, or GOES East-West is literally destroying flat Earth every 10 to 15 minutes. And I'm going to answer all their main objections, so you'll have no doubt that these images from space taken every 10 to 15 minutes, every day, 365 days a year, are real. I kind of want to just start with this little video clip here, just to show you just kind of zoom in on one of these Himawari 8 images and just show you the amazing detail. It's 11K by 11K resolution. It's the advanced Himawari imager that is taking images in 16 different spectral frequencies. And it puts together these images within the visible band into very vibrant, colorful images. But there's many other images they take and use for meteorology and weather. And you can see an image of the advanced Himawari imager right here, which is actually made in the US. And a similar imager is used in the GOES 16 and GOES 17, or GOES East-West. So it's just an amazing technology that we're getting 11K resolution that allows you to see down to a half a mile or to 2 miles, depending on which spectral band is being taken. And the frequencies that are being used are within the far infrared to the visible. And we're going to see how this comes into play with a lot of the objections that they bring up. So here you can see kind of an example of the 16 different bands that are being taken. So this is not just taking a snapshot. This is, again, we have to realize this is for meteorology and weather. These images are not meant to convince flat earthers that the Earth is round, because we've known this since 300 BC. These images are taken to help, not only with weather, but as we'll see, to help with fire prevention, floods, volcanoes, just all kinds of other things that can be observed from space that can actually save lives. So here is just kind of a list. I mentioned a few of them already, but there's just many applications for these 16 different frequency bands that are being taken pretty much every 10 minutes. So again, just kind of take this in, all these different applications within these different spectral frequencies. Now Joe Rogan has had some guests on his show, and the whole flat Earth topic has come up with him. And I know Eric Dubay was trying to challenge Neil deGrasse Tyson on the Joe Rogan show, and there was kind of all this kind of stuff going on around that. But Joe, just kind of reading his thing here. So for all you people that have bought into this flat Earth nonsense and continue to leave comments that they don't believe the Earth is round because every photo of Earth is a composite, I present to you this, one of many, many images taken by the Japanese Himawari 8 satellite. It takes full Earth images in high resolution from 22,000 miles above the Earth every 10 minutes. Just the fact that this exists, and yet all these people have been arguing that there are no full images from Earth, from space, should tell you the level of bullshit that's involved in this stupid fucking theory. There are perplexing things to ponder in this bizarre and fascinating universe, folks, but this ain't one of them. Google is your friend. So I just love this post, and it caused quite a stir within the flat Earth community. And of course, it just got all this pushback. But anyway, he's right. The Himawari 8 is a flat Earth killer. I mean, destroying the flat Earth every 10 minutes, absolutely annihilating it. And so it's just, I just find this humorous. And it is worth noting here, I just want to bring this up. go over to my friend MC Toon's channel, and if you haven't subscribed to his channel, MC Toon Live, and definitely subscribe. But he recently he recently did a video challenging, because evidently Bryce Mitchell, along with Shaquille O'Neal and who else is a well-known flat Earth, Bob the Rapper, Kyrie Irving. I mean, there are some prominent people that are believing the Earth is flat. But now we got another one from the UFC, Bryce Mitchell, who is basically challenging Joe Rogan to a debate. And of course, Joe Rogan's not a professional debater, so MC Toon has this challenge, because MC Toon is definitely one of the best flat Earth debaters, and challenged Bryce to a debate. So I would love to see that. In fact, he said that that him and FTFE would team up against Bryce and Bryce has got a friend in the flat Earth community. I can't remember his name off the top of my head, but I would really love to see that. So now I want to kind of show. Today we're not going to pick on Witz's day. Today we're going to pick on Jaronism and Dearth. So I want to first play this clip from Jaron, and he's basically talking about the stitch lines. And again, he's not understanding how these images are made. But let's just hear Jaron first, and we'll get into debunking the heck out of what he's saying here.
There's stitch lines. You can see the stitch lines inside the Himawari 8. So
yeah,
they're not.
You zoom in, you see where it's stitched together.
They're purple stitch. I can show you if you want.
Yeah, zoom in. Someone zoom in on it.
I'm going to show you. Can you see this?
Let Jaron bring it up.
Can you see my screen now?
Yeah. That's your screen.
So this is Himawari. It's live. I'm just going to find it.
Okay, so now the first debate, I have to admit, I wasn't aware of exactly how the Himawari images were created. But certainly after this first debate, it was an eye-opening experience for me, because keep in mind, this was me a total of 6 weeks into flat Earth, like just studying all their points. These guys have a combined total of over 20 years of responding to these points. So I really didn't know what I was getting into. And on top of that, Witzit wasn't supposed to be talking, and he ended up talking the most. But that's another story for another day. But just to getting into Jaron's stitch idea, let me just play this little animation. You got to understand how the advanced Himawari imager is taking these images. It's basically scanning, and you can see it right here. It's scanning through 20 lines here, and this takes a total of 10 minutes. And you'll notice that it's scanning doubly in certain areas. So it actually, because it's a Japanese satellite, it's going to scan a little bit more up in Japan. And if there's any like hurricanes or any weather anomalies, it might scan. So it leaves some room. And the GOES 16 and 17 does this too, where the GOES 16 and 17 will scan the US. And that's why it takes 15 minutes with the GOES, because it's doing more additional scanning. And if there's a hurricane, like say Hurricane Ian, it will be scanning that much more frequently to give. And again, the more frequently it's scanned, the more you get more up-to-date sort of animations, as far as the animations become more real and more dynamic. These flat earthers, they just think that this is like a big Kodak camera up there or something, just taking a full Earth image. And so they'll use these photo forensics software tools. They'll say, oh, look, it's a composite. You can see over here, it's a fake image, not realizing how the imager is actually taking the scans. And again, you got to remember, these are weather satellites. They don't care about what flat earthers think about composites or whatever. But they're cleaning up they're combining the colors in the color spectrum. They're doing other interesting things in the other spectrums, and they get a whole bunch of different images that have applications to different things. And they will even clean up these edges here. In fact, I took a recent image of actually today's Himawari 8, and I put it in photo forensics, and it's not this choppy here. Actually, they clean it down, but you can definitely see the cropping there. But just because there's cropping doesn't mean that it's fake. I mean, these are real images. It's kind of like when you take those panoramic shots with your camera. Just because it's a composite of many images that give you a panorama, it doesn't mean that it's not coming from a real image. Flat earthers just don't understand photography, and they just think because something's a composite, or that it's not taken all in one frame with a Kodak camera, that somehow it's fake, or it gives them justifications for it's not real. So if you're really interested in all the different refinements that they do, listen, flat earthers, they're not trying to hide this. Even on the Himawari website, it gives a link to this journal here, and I'll put a link below in the comments. They actually tell you flat out all the different things that they do. And I don't want to get into it in this video, but they do a lot of things to clean up the image and to make it look better, to enhance it. Again, they're not trying to prove the Earth is round. They're trying to get the best images for weather forecasting and for other purposes. Now, one of the other things that Jaron brought up, I didn't have it in the video clip, but he was saying that there should be images of the moon in the Himawari, in these Himawari shots. And of course, they just think they're like Paul on the Plains says there should be some big panorama of stars in the background. But as you just saw, they're not trying to get the moon and the stars. They're trying to be very efficient because, for example, if you take the whole rectangle versus a very thin strips like you saw, it ends up costing you like 21% or something like that more time. So they're trying to make this as efficient as possible to give the most up-to-date images. They're not trying to photograph the moon and the stars. However, when the moon is really close to the edge like it is here, it does come in. So Jaron and you guys that say we should be seeing the moon, there actually are Himawari images with the moon. You can even see Betelgeuse here in the stars. But again, because of exposure, flat earthers tend to think that the stars should just be lit up. But again, if they did that, the whole Earth would be washed out from the exposure. So to get a really good image of the Earth, you can't have the exposure opened up. But some bright stars like Betelgeuse here will show. Okay, so let's debunk Jaron again here. Let's see what he has to say now about this 10 to 15 minutes.
Why would you ever accept 15 minutes late for an image of the Earth?
You would think these guys by now would be understanding that how these images are made. So I just explained how it's a 10-minute process to scan those 20 lines. It takes the Himawari 10 minutes. And they also brought up that sometimes it's down for some time, like 25. Well, that's because there's system maintenance stuff going on whenever it's down, when it takes longer to get an image. So again, that just debunks the whole 10 to 15 minutes late thing. And I already kind of went through with the Himawari how they scan different parts. So it's not just going 20 lines across the globe and just getting the one side of the globe here. They're actually doing extra scans over like hurricanes, and if there's like bushfires or some other things going on. They're able to target areas that need more frequent refreshing and updating, especially when lives are at stake. So here's a nice little image of the GOES 16. And what you're seeing here is the scanning schedule for the GOES 16. And it's going through and it's doing extra on the US. So that's why this is taking, and here's the whole schedule kind of laid out. But it's essentially going through, and it takes 15 minutes because they're just getting more information on the United States. Now, obviously, the United States is a bigger country than Japan. But otherwise, they're very similar type of cameras, and they're pretty much taking the scans in very similar ways. In fact, I think Harris even makes both of them, if I'm not mistaken. American companies making both of these imagers. So it's just that they're both programmed a little bit differently. Okay, so now let's get into some Dearth here. So Dearth, again, like I told you with my initial email from Dearth, he's basically saying this is like one of the best things and it's going to basically shake my worldview. And so let me just play some of the stuff he was saying from the first debate. So let's hear what he has to say.
We found a server. Jaron, jump in at any time.
Yeah.
Either whistleblower or somebody found us an FTP server with tens of thousands of folders on it with images from the Himawari 8, and it had a blue marble, a regular blue marble model, and then it had flat images of world radar, and it was showing how they wrap it around a sphere. This is a NASA FTP server. I'm just going to jump forward a little bit here, and so here's one of the maps they use with the weather on it. These are images that were on these servers. And then, so check this out. This one is, they got the blue marble. They wrapped the weather data around it, okay? And we take it a little farther. This is the folders that we got it off of their FTP server. And then they added a terminator line, right? They added a terminator line. So here's the question for you. If this is a real image from the Himawari 8, how did we see the clouds over here?
Okay, so David, there's a lot of things wrong with what he just said. Now, let's first start with the blue marble data set. Actually, that's not true. In fact, if you look, the Himawari 8 is not using the blue marble data set. In fact, they actually will tell you right on their website. Again, they're not trying to hide anything. It actually says right here, the details are as follows. First, the AHI, which is the Advanced Himawari image data, and the pre-processing of the AHI image is performed, including geometric correction. So again, yes, they do sometimes, like with the infrared at night, they do need a base map. But having a base map is incredibly common practice. Just so you line up and have the image in the right place, because sometimes there's cloud cover, sometimes it's night. So yes, but they're not using the blue marble base map. They're using the WGS84 projection. It's right in the Himawari standard user's guide, so you can see this for yourself. And I'll put a link below the video here on this. So it's the World Geodetic System 1984, standard use for cartography, geodesy, and satellite navigation, including GPS. So it's just a very standard blueprint that they can overlay these actual real images and to make sure that they're all lined up properly. This is standard practice. There's nothing wrong with this. And it doesn't mean that the images are fake. It just means that they're trying to get everything accurate and lined up. Again, especially at night, and especially when there's heavy cloud cover. Again, this is something flat earthers don't understand science, and they don't look into how the professionals do their job. And just in case any flat earthers are watching, just so you get a little education here of what a base map is. A base map is a layer with geographic information that serves as a background. The base map provides context for additional layers that are overlaid on top of the base map. Base maps usually provide location references for features that do not change often, like boundaries, rivers, lakes, roads, etc. And again, when you look at some of the Himawari images, you will see that they allow you to put in the boundaries for countries and other things. So again, that requires a base map. Standard practice. There's nothing fishy here, and they're not trying to hide anything. Again, this is right in the Himawari 8.9 user guide. If they were really trying to hide this, you think they would make it so easy for everybody to see? Okay, now oh, dearth. So many things you get wrong. So what he was finding in these files, part of what he was seeing in these files is annual globe temperature simulations. This has nothing to do with cloud cover. Basically what he was trying to say is they're taking these images, and we'll see in a minute he talks about Doppler too, and combining that and wrapping it around to create the images that we see, and it's all somehow faked, and there's artificial intelligence, as we'll see in the next clip that he's got to say. But what I want to bring up now is these are images from over the ocean, and there's nothing to do with cloud cover. You can't get cloud cover from this. And again, all weather simulation, and you know how inaccurate weather forecasts are. They're certainly not going to be able to predict cloud formation or cloud cover. I mean, no way. I mean, why would they even do that? Now, temperatures, like if you look at farmers' almanacs and so forth, yes, temperature variations, there are kind of statistical things that go on with temperature now. And that is much more predictable. I am much more predictable than, say, cloud cover and the weather. So all this is temperature fluctuations. You can't create anything to overlay across the base map to create all the complex clouds that we get in the sky. This is just absolute nonsense. And again, think of that initial image I showed. We're talking 11K here. Oh gosh, it's just so ridiculous. Okay, so now, so Dearth was not understanding what this image is right here. So remember I talked about there's 16 different spectral bands that are being taken every 10 minutes. They're taking these images in all these different frequency bands. And 3 of them are the color that give rise to the visible spectrum. Now, what this particular image here is, it's an Airmass imagery, which gives a lot of good information for meteorologists. Okay, it's nothing to do with wrapping around to create. It's not like this is the fake and then they airbrush it or do CGI to make it look like the images that they present. No, this is one of the many pieces of information that meteorologists need. And you can see over here, what's so cool if you look this up, these Airmass imagery photos will give all kinds of detailed information about And they're actually overlaying now many of those different frequencies all on one. So this is not just visible spectrum. This is also including near infrared, middle, and a little far infrared, I think. And so it's given them all this information because these different types of clouds and these different types of moisture in the jet streams, they all light up, or they all become visible more or less in these different frequencies. So this is a very, very powerful tool for meteorologists. So now with the terminator line, I want to really show how this is just nonsense. So so over here, this is from today. I have the Himawari 8, and I picked a time where the terminator line is pretty noticeable here. So I hope Dirth is watching because he needs a little education on what's going on here. Now, what's really interesting is you can take this image now, and this is Himawari. I'll put a link below this video so you can see this for yourself. Is you can do the 24-hour, and now what we can do is we can look at this image in different frequency bands. So we got kind of a more of a red dominant here, but notice you can still see the terminator line over here. Now, again, this is kind of the base map in the background, so it's not going to be dark like the previous image, but you can still see it's bright enough over here where you can see the terminator line. But now let's look at something here. Notice that now we're going into near infrared. Well, we're still seeing a terminator line. Okay, 1.6 micrometers, we're still seeing a terminator line. Let's see, 2.3, we're going to still see it? Yeah, we're going to still see it. Now, what do you think is going to happen next? Does anybody think you're going to still see the terminator line at 3.9 micrometers? No. What just happened there, Dirth? What just happened there, flat earthers? Well, I don't know if you guys know this, you probably don't, but the sun is coming in mainly with visible light and infrared. That's almost 50-50. There's a little bit of UV in there too. But now the Earth, as a hot body, will absorb and reflect some of that, but it also will re-radiate between 4 micrometers and 30 micrometers. So what you're seeing here now is near infrared, right at 4. This is right where the Earth will start to re-radiate. So now if we had the eyes to see infrared, the Earth would be lighting up at night. And this is how infrared goggles work in the military. And I had a BMW, I don't have it anymore, one of my previous BMWs I had a infrared camera. So I could see things at night, right? We've all seen this. So what happened to the terminator line? Were they painting it in, Dirth? Or were they looking at the images in a different frequency band? I'll give you a hint. It's the second thing I said. So what Dirth is saying, he just doesn't understand how this works at all. He doesn't understand how it works. Okay, so let's debunk Dirth again. Let's see here. Let's see what he has to say about Doppler radar.
So hang on.
Composite,
here's my question.
Sure.
You agree that there's radar stations all over the world that could map out on a flat map all of the weather patterns in real time. So they can take that data, and no human has to be involved with this, wrap it around a globe, put a terminator line on it, and send it over to NASA every 10 or 15 minutes.
I don't know, Dave, that would take 10 or 15 minutes to do that.
No, it wouldn't. It would take 1 second to do because AI now can draw a picture from a description that you make and make it look photorealistic.
Wow. I mean, just almost everything you just said there is wrong. So Doppler radar, let's first look at some problem. Doppler radar does not image clouds. It's imaging like water vapor in the cloud and wind speed and some other things, pressure. There's things that Doppler can see, but it can't give you detailed pictures of the clouds. In fact, on some days, you can go look out and see some thin clouds and go, to the weather satellites and you won't see anything. So you absolutely cannot get these clouds from Doppler. And the other problem is there's no Doppler over the oceans. But then, Dirth was saying, he pointed to that image, which was temperature maps. You're not going to get cloud cover from temperature maps either. So, and then they got supercomputers somehow that's doing artificial intelligence to put all this together from Doppler and these images of temperature maps that neither of them can give any cloud cover type of imagery. So how can supercomputers and artificial intelligence do anything with that? Oh my goodness. I mean, just pretty much all the words, all those little video clips I showed, almost everything that those guys were saying was wrong. And even if you invoke weather balloons, that doesn't work either. Every 10 to 15 minutes, weather balloons are all over the place, but they're not even covering the whole globe. And they only last for a few hours, and I mean, they are released every day, and they do give useful information, but there's no way that they can recreate these images from space that we see from Himawari. Again, with that 11K detail every 10 minutes. Joe Rogan was right. This is a flat Earth killer. And I just answered and obliterated all your objections to it. Oh, the one thing I forgot to mention with those files from the server was they do have, for marketing purposes, for people that want to use these images, they have some files that they create for these purposes. So it's the actual images that we're getting every 10 to 15 minutes are live images. They're not based on predictions. They're not based on CGI. They're not based on any type of weather forecasting in the future or temperature maps. They're live photos that are being scanned every 10 to 15 minutes. And I challenge any flat earther to respond to this video to the points that I make and tell me how that I'm wrong about what I've just said tonight. Now here's some things that Doppler radar can't give you, Dave. Crepuscular ray shadows. Wow, look at this. These are very ephemeral. Is Doppler going to give you that? No. You're not going to get that from Doppler, but will Himawari? Yep, Himawari will give that, as will GOES 16 and 17. So I just want to play this little video clip where you can actually see a flood happening in real time in Australia. And this is from Where's Wally, who's got some great videos on the Himawari 8. And you can see the water coming in. So again, Doppler is not going to catch this in floods. And again, that's one of the things that the Himawari 8 and the GOES East and West can do, is they can help with fires and floods and just a lot of things to help us to save lives. So this kind of comes to the last thing I want to conclude with here. It's just more examples of what I just showed you with we call them truth observations. So now they're actually, when it comes to fires, one of the purposes of Himawari, one of many, is that it helps with fire prevention and being able to track fires as far as which direction the fire is going and different things like that. And there's actually a really good research paper, I'll put the link below the video, that goes through using Himawari 8 to track wildfires. And this one right here was a 2015 wildfire in Mongolia. Now here from the GOES satellite, GOES 16, you can see images of the wildfires in 2017 in California. And again, they're able to get some really good data here as far as like which directions the fires were going. And again, just just a lot of useful information that can be used to save lives. Again, this is not anything that Doppler is going to be able to pick up. Now, now tracking hurricanes. Now, the first one here is Hurricane Irma. I live here in Bradenton, Florida, so I actually went to Atlanta when Irma was coming because I was right on the sea level. Now, for Hurricane Ian that just happened, I actually stayed here, and it did go a little bit south of us, thankfully. I mean, I feel bad for Fort Myers and Port Charlotte, but it could have been a lot worse for me, but it was still pretty bad. But I actually took this capture here from the GOES 16 website, the live images, and this is the one from when it hit landfall. I wanted to take the one right when it got to landfall. And so again, I was tracking this in real time as it was happening. So it's, it was scary, but it's also, in this sense, it's kind of cool to see GOES 16 in real time. And I'm right here. I'm pretty much, I'm up here. I'm just a little bit north of the eye here. Okay, so another interesting thing that was captured was here you can see a beautiful solar eclipse captured from Himawari. That's not something that a Doppler radar is going to be able to get. Just really beautiful. I mean, just amazing. And then we have the University of Wisconsin-Madison capturing an eclipse within the U.S., as you can see right here. See come right across. I mean, just so amazing, this technology. Just an absolute flat Earth killer. Himawari 8, GOES 16, 17, just flat Earth killers. I mean, every day every 10 to 15 minutes, just demolishing flat Earth. Also, volcanic eruptions are seen from space. And here you can see the Himawari 8, and even the ISS, I think, got a shot of this. Just beautiful, beautiful images, just capturing. And this is more of an animation from an eruption of Mount Sinabung in Indonesia from the Himawari 8. And you can see it, and again, in real time. You know, if you were able to, hopefully you're not in the location where this is happening, but if you're somewhere in the distance where you can see it happening, you could go on the Himawari 8 website and you could see it from space at the same time. Just amazing how you can do these truth observations. So in this sense, it's kind of a one-up from the blue marble and these Apollo images, which were real images. But with Himawari 8 and GOES 16, we can see the image and we can look at clouds up in the sky and we can go to the website and say, look, there's the cloud. It looks just like what I'm seeing. I mean, if that's not proof, and you just couple that with the fact that Doppler can't create clouds. So that's all I got. So I hope you enjoyed this video, and I hope you've learned a little bit more about Himawari 8 and how it is absolutely one of the best pieces of evidence we have that we live on a globe. So thanks again, and you have a wonderful rest of your night. And do like this video, leave some comments. I love the comments from you guys. I'm always learning things because there's a lot of very smart people that watch these videos and leave some really great comments. So I'm always learning new things when you guys leave comments. And subscribe to my channel. I have many more videos coming. All right, well, have a great night.